In this video, we'll be reviewing a few properties of functions and how we mathematically describe those things. Starting off with a trait which we call increasing or decreasing. So I'm sure y'all are familiar with the idea of a graph and obviously whether something is getting bigger, getting smaller. But there are a few little things and the way that we write intervals of increasing and decreasing which are a little bit not necessarily obvious. So on a graph of a function, we'd say that the function is increasing if it's going up, obviously. But notice in a graph, say for example, between points A and point B, we would say it's increasing. Another very important thing about intervals of increasing and decreasing is we always consider the function as from left to right. Because notice if I was to go backwards in this curve, let's say I was to go from point B to A, you might say that that's decreasing because, right, it seems like it's going down. But we're always going from left to right, and that's just always the way increasing is defined mathematically. And same goes for decreasing. So we'd say A to B is increasing, whereas B to C is decreasing. And then from point C to D, we're going back to increasing. So clearly on a particular interval for this random curve, which is not pertaining to a formulaic function, we can see obviously it goes up, it comes down, it goes back up. And this is how we mathematically describe those intervals. Now also, additionally, one thing about intervals of increasing and decreasing is we always are going to use the x-axis or the domain, if you want to remember it that way, for describing those intervals. We don't want to use the elements of the range to do that, and there's a specific reason why that we'll get into when we look at an example. And also, another reason we must do it from left to right is usually in a lot of problems, the x-axis is often, like, for example, the flow of time. And let's say we were imagining that this graph represented the size of our bank account as time progresses. Time flows from left to right, or it's always increasing. And that's just a general way we read graphs, is from left to right, just as we read a book. And that's why, we define it that way, which is why you got to be a little careful. But let's say this graph below, function w of x stands for a person's weight, let's just say in pounds, or it's labeled in pounds, at a particular time in their life where x is in years. And then we're asked what intervals is the person's weight increasing versus decreasing. And obviously your weight can be constant as well. It doesn't necessarily have to be going up or down. But in this particular function, it appears as though, when they're born, well, it looks like they're 0 pounds, which doesn't exactly make sense, but we'll kind of ignore that. And it looks like from ages 0 to 25, their weight is increasing, right? And again, it's done from left to right, which just makes basic sense. And as I said, we would describe that interval. We're not going to be using their weight to describe the interval, but instead their time frame. And it's, again, as I said, it's always going to be done using the x-axis. So if we kind of connect those 2 points down to the x-axis, we can imagine, well, what is that interval? But it's from 0 to 25. And you might be wondering, if I'm writing it in interval notation as I would the domain, should I be using brackets or should I be using parentheses to describe that interval? And that's a good question. Well, I asked the question, but you might have been thinking that. But technically, it really depends on the source, and it depends on the way intervals of increasing and decreasing are defined. A lot of sources would use the parentheses around 0 to infinity, which would indicate that it's not increasing at 25. Because if you think about age 25, it's not clear, well, is it increasing or is it constant, because it appears to flatten off. And so, it's all about, well, is the boundary point included or not? And the online homework might be very specific about which it wants. And honestly, I can't remember which solution it deems correct, because some books will mark one wrong and the other right, and vice versa. So to be honest, I don't care which answer you would to do it on a test. But for my math lab, just pay attention to which way the book describes it, which I would say it's generally more common to accept the answer with parentheses. And then so anyways, but then we can see from age 25 to 35, that person's weight is constant. So it's neither increasing or decreasing. So we would say from age 25 to 35, their weight's constant. Then it looks like from 35 to 40, they gain some weight. Again, I'm doing my best guess. And when you have a graph and you're trying to interpret information from it, it's not as exact because we don't have any calculations to run. We're just trying to visualize, but 35 to 40 seems like it's increasing as well. We would use the union symbol to join two disjoint sets together. And all this means is that their weight is increasing when they were either between 0 and 25 or they were between 35 and 40. Then between 40 and 50, it appears as though they lost some weight. And then from 50 to, well, I guess it looks like about 80, their weight was back to constant. And the graph just sort of stops, so we don't know what does that mean, they died or what, but we could say that that's the end of the domain that we're given. And I guess we'll just leave it at that, and we won't be too morbid and think about, you know, what happens when it ends. But anyways, the main point here is this is how we describe these intervals, is by using interval notation, we can join distinct groups of the intervals using the union symbol. And over the course of a function, it's going to be one or the other, or well, one of the three. It's either going to be increasing, decreasing, or constant. So we can examine the entire domain and break down each of those intervals into parts. Another thing you might be wondering is, say we had a mathematic function like f of x is equal to x cubed minus 3x plus 4, and you're wondering, well, how would you figure that out without having a graph? And actually, that's one of the many tools you will learn how to do in calculus. And in calculus, we use the same notation to write these intervals. So it's kind of the reason why we're getting into the basic practice of how to write them is because you're going to be doing this again in calculus, and you're going to be learning other techniques of finding this. But if you ever get stuck on a question in calculus, you can usually graph your function and look at it that way. Now, one other thing you can do with a graph is you can find what we call the extremum, or the extreme values of a function. Or, you know, that's just a mathematical word which means either a minimum or maximum, aka what is the largest value or the smallest value that the function attains. Now, with extreme values, it's always with respect to the range or the y values of those graphs. It doesn't have anything to do with the domain. But what we're often looking for is the points at which it attains a maximum or a minimum. Like in looking at the weight example, if we were asked, well, what's the maximum value of that function, it would be implying that what's the maximum weight the person attained, or, you know, what's the top point? Obviously very easy to identify using the graph, which is at age 40. You know, we could write that, we typically write that as an ordered pair, which again can look like interval notation, but it means something different. 40, 200 was the maximum, or we would call it the extremum. And again, extremum just means either min or max, so it's a blanket term for either the top or the bottom, but that would be our maximum. And we refer to this as an absolute max value because that was the biggest they were ever in their entire lifespan, 200 pounds. And also remember, this means at age 40. And again, it's input, output. Input is their age, output is their weight. Both of those are part of the maximum, but if you're ever asked for what's the maximum value, that usually implies just the y value. So it kind of depends. If you're wondering, how do I write my answer? It could be either way. Sometimes it might ask you at what age are they their heaviest, or what is their heaviest weight, or what is the coordinate, you know. Anyways, that's what you got to pay attention to. And then for minimum value, that would be, well, what is their smallest weight attained? Obviously, that would be when they're born, which it appears to be 0. So again, that doesn't really make sense, but it appears as though the origin is the absolute minimum here. But, you know, in reality, it's probably more like 0, 5 or 6 or whatever their point really should be. In the next video, what I want to do is teach you, well, how can you take a mathematical function or a function defined formulaically and find this information in the same way. And basically, it's kind of the same idea. We could use our calculator to graph the function and then find all the information just by looking at it. But there are a few tools in the calculator that I wanted to show you how to use, which can be a little bit tricky to use. So that's why I want to do a little mini tutorial on that. Again, this is all really helpful in calculus. You can solve a lot of calculus questions with a calculator, but the whole point of calculus is, well, how could I do this using like algebra, or not algebra, it's using calculus, but it's sort of like, how would I solve it mathematically rather than graphically?